Hello and welcome to the course on C Programming Learn to Code series. This is the 16th lecture of Unit 2, and in this lecture we will discuss the concept of floating point data type used in C. So let's begin. Let me first introduce what do you mean by a floating point number. A floating point number is a number that contains a floating decimal point. For an example, 3.56, 7.89, 9.33, all these are representing a floating point number. Then which are not the floating point numbers? For an example, 5, here 5 is an integer, √2, so these are not floating point numbers. So now let us discuss what is the facility provided by the C programming language to represent this floating point number. Or suppose in our program, if I require some floating point number to solve our problem, then what facility C programming language provides us? So in generally speaking, to represent a floating point number, C provides three different keywords. So the first keyword is float, and the second keyword is double, and third is long double. So why three different keywords? They all specify with some precision value, and everyone takes different size in the memory. So if you need more accurate result, then you could use long double. If you require a slightly reduced accuracy or reduced precision, then you can use double. And if you don't consider any precision, or you require very less precision, then you can use float. So everyone takes different size in the memory. We will talk about that in the subsequent slide. So let's begin. So that now I know that there are three different keywords to use to declare variables in floating point number. Then how to declare it? So the first one is how to declare the variable. The first one is float weld. So here weld is a variable which is of floating point type. So whenever you declare like this float weld, then the compiler will automatically allocate space for the variable weld, and we can store any floating point number inside that. So this keyword specifies that we are about to store a floating point number in the space allocated. Okay, so this is the declaration. You can also initialize some value in the declaration line itself. So how to do that? You should write float weld is equal to 7.65. So if you write like this, then 7.65 will be assigned to that allocated memory location. Or you can write it in a two separate line, something like this. You will declare the variable weld in one line, that is float weld. Then we can write weld is equal to 7.65 in the second line. Both considers the same purpose, or both are representing the same purpose. That means declaring a variable and storing a value. Similarly for double, you can do something like this only. So double weld, you can assign the value directly when you are declaring the variable, or else you can write it in two line, that is double weld, then weld equal to 7.65. Finally, you can also use long double to do the same thing. Okay, so that is all about your floating point keywords and how to use this keyword to declare variables. Now in the last that I am going to talk is the final table, where I'll show you everything about all these keywords. Like whenever you are declaring a variable using float keyword, then inside the memory 4 byte gets allocated, and you can represent the minimum value will be 3.4 e minus 38, and the maximum value you can represent is 3.4 e plus 38, and the precision that you get here is 6 digit. Similarly, if you represent a double, then the storage size will be 8 byte, and the minimum value you can represent in that space will be 1.7 e minus 308 to 1.7 e plus 308, and the precision that you get over here is 15 digits. Similarly, or finally, if you use long double, then the storage size or number of bytes allocated by the compiler is 10 byte, and the minimum value that you can represent over here is 3.4 e minus 4932 to 1.1 e plus 4932. So this is the range of your long double, and here the precision you will get is 19 digits. Now you may be wonder, what is these values if you don't know about the scientific notation of representing a floating point number. Actually these are the E concept, exponent concept is given. E stands for exponent. These concepts are representing a scientific notation to represent any floating point number. In computer system, generally IEEE 754 standard will be followed to store a floating point number inside the memory. But as this course belongs to your C programming language, we cannot discuss this IEEE 754 format here. If you belongs to computer science background, then you will get means you are about to take a course that is called computer architecture. There you will learn about IEEE 754 format to represent a floating point number in memory. That time you will easily understand how the floating point numbers are actually represented in memory, and if the number of byte size is given, you can find out what is the minimum value or the maximum value of any required, means how many byte, means if the byte size is given, how to find out the minimum and maximum value of representing a number can be found out. But still we can explain something over here. So we can explain something over here about the scientific notation. For an example, let's say I am taking a number, let's say 1.3962857. Let's say this is the number given in scientific notation E5, let's say. Okay, so it should not be plus, E plus 5, let's say. Okay, so suppose this is the number given 1.3962857 E plus 5. Then how is actually it is represented? It is represented something like this in your decimal form: 1.3962857 into E plus 5 means it will be 10 to the power 5. Okay, so that means it will be 10 to the power 5, so which is nothing but 1.3962857 into 10 into 10 into 10 10 into 10. So which we can say it will be 1.3962857 into 5 times 0, right? So when you multiply this, what you will get? You will get 1, the decimal point will be shifted towards right, so that will be 396285.7. okay, so this will be the not 0.7, 5 times 1 2 3 4 5 5 7, sorry, so this will be 13962.857. actually the decimal point is here, so whenever you see the exponent value is given plus 5, then the decimal representation of this scientific notation will be shifting the decimal point towards right 5 digits. So 1 2 3 4 5, so I have shifted, the decimal point is actually here and it's shifted to here. Okay, this is how a normal decimal number is represented. So that means we can say this is the decimal number given to you, and in scientific notation it is represented like this, right? Similarly, suppose a decimal number is given something like this, let's say 1.396835 E minus 3, let us say. Then this is the scientific notation. So in decimal form it will be written as, decimal or floating point form, it will be written as, you have to shift 3 bit towards left, so it could be 0.001396835. so this is the decimal representation of this number. Got it? So you might have read about this in your mathematics subject, but if you don't know, this is the way a scientific representation of a decimal point has been done. So here I am representing the minimum value and the maximum value with scientific notation. Okay, so that's the thing. I think you understand what is a floating point number. That's all for the today's class. Thanks for listening. Bye bye.